We're going to go on now to section 3, actually, which is referred to as intercepts. Now, we did mention this in previous sections. In fact, I'm going to put up my special T-chart over here, which I'm calling the X and Y intercept T-chart, where if you have a 0 there, this is in the form 0, comma B, that would be your y-intercept. If you have A, comma 0, that is your x-intercept. And to start us off, we want to define what is an intercept. Well, by definition, an intercept is where your line will either cross the y-axis here or the x-axis there. And here, this would be a linear equation, and we're looking for the intercepts. Here, this is sort of a curvy equation. And again, my diagram's not too great, but we're looking for the intercepts. And we could just put them into some sort of chart. So for this one, if x is 0, it intercepts here at -8. So there is our y-intercept. And then if y is 0, it's intercepting the x at 2. So these would be your answers. Now for letter B, they're asking, what are your intercepts? Well, when x is 0, y is 1. And then here we have actually 2 x-intercepts. It's crossing it at 2 points. Now here your y value is 0, and 1 will be a -1, and this one is a -4. In one of your later courses, the college algebra course, they're going to say, find the zeros. Well, it's for something like this. And it's when y is 0, what value would x have? Going on to example C of part A there, or example 1. Here is a line going through the origin. So actually, it is the origin, 0, comma 0. That is both your x and your y intercept. Now, as you look at letter D, this is equation 6 over here. It's a vertical line, and that is going through an A point, which is an x-intercept. So here it's going through 2, comma 0. There's only an x-intercept for these. As when we do number 5, there would only be a y-intercept. This is your y-intercept. This is your x-intercept. So here, your x-intercept. When you have a circle or an oblong figure of some type, you pick out each point. Here it's a -1, 0. Here it's 0, -1. This is 0, 2. And this is 3, 0. Now, in this example, and I guess those were examples 1 through 5, they want us to solve and graph using the intercepts. So we had introduced this before, but now they're saying that's the way they want you to do it. So I've put up my little T-chart there, and I'm going to do some points. If x is 0, this is 0, this becomes a -2. If this is 0, x is 6. So now we make a graph, or in your math program, of course, the graphs are already there. Notice there's a little device here to make them bigger if you need it. 0, -2, a dot there. and then 6. 1, 2, 3, 4, 5, 6. And then using your ruler, off a little bit, but you get the idea. So again, identifying the x and y intercepts to do your graph. Now, later we're going to see other methods for graphing, but if your instructions is to solve by finding the intercepts, this is the way you have to do it. If you don't show the intercepts, they're going to count it wrong. So again, it's a good technique and something you want to practice. As we do these next two, 7 and 8, there's a little twist to it. Notice that here, if we use the x and y intercepts, that if x is 0, y is 0, and vice versa. So this is actually going through the origin, and there's a reason for that. And let me go over the reason while I'm here. See equation 2. If I solve this equation for y, x equals a negative 2y, I'm going to divide both sides by a negative 2. I get then y equals a negative 1/2 x. And notice there is no b term, which we said that was the y-intercept. So when there is no b term, our intercept is the origin. So this equation is going through the origin, so we would need another point. So I'm going to use a 2. If x is 2, I divide both sides by a negative 2, so this is going to be a negative 1 here. If x is 2, this becomes a negative 1. I divide both sides by a negative 2. So I have then 2 negative 1 right there. So there's my line here. So my x and y intercept is the origin. I needed another point to plot it. Now for example 8, as you look at it, is it in standard form? And the answer is no. And we said if you want to use the x and y intercept t-chart, if it's in standard form, it's much easier. So let's put this in standard form by bringing the y over. 4x minus 3y equals a negative 9. So that's the modification I'm going to do. Now if x is 0, this is going to be a 3. And if y is a 0, this is going to be a negative 9/4. All right, that's sort of a hard one to do if we're using the intercepts. And we may need some other point, but let's give it a shot. So there's 0, 3, 1, 2, 3, right there. And then now a negative, remember a negative 8/4 would be a negative 2, and we're just like 1/4 over. So it'd be something like that. Okay, going on to our last two topics of section 3 on intercepts, we want to graph horizontal and vertical lines. And notice we have it set up over here. And these numbers are just reference numbers. When I say formula 1, standard form. Formula 2, slope intercept. We'll be doing this in the next section. and then the one after that, and we're doing these two now. And by the way, what I would suggest is to take this and put it on like a little index card that you might have as reference. These are excellent things to be familiar with. And as you look at your card from time to time, hopefully it will sink into long-term memory. So formula 6 is x equals a. This is your x-intercept, and it's a vertical line. So there's your graph. Where is a? A is 2. So there's the graph of x equals 2. It should be going to 2, I'm a little off there. And here, y is a -3, which is our y-intercept. -3 is right there, and there is our graph. Okay? So again, you'll have practice, your quiz me's. Hopefully this is helpful to you. And keep in mind, this is all in your textbook as well.